Hello everyone, welcome to Dcademy for class 12 chemistry class. So, mamangi classes singda akoina unit number 1 solutions habasi khara kupthana nina ba yogre ko. Habadi akoina solutions ki types myam ama nina khre sikata natana factors khara nina ba hograbani. So, sida vapor pressure karino Raoult's law kana bu khangage then Henry's law na kanano ko Henry's law ga Raoult's law ga ani sigi marka laiba relation duna karino habasi so koi khaminagre. Now, today we are going to study relating to the azeotropes. After the azeotropes, we are going to study about the colligative properties. So, in the previous class, the last topic we discussed was ideal solutions and non-ideal solutions. Ideal solutions amasung non-ideal solution have a kari no have a matanga akoina nene yariko. So, ideal solutions hai taragadi Raoult's law obey toba. The non-ideal solutions have been around so to obey the vidaba and high greba. Yareko. Adukatanatana, Kaiguma component ani yawasida, Ega, Biga, Anisigi interaction siga, A or BB, Aniki interaction siga, Chapmana Taragadi. It will be termed as ideal solutions if there is differently ram Taragadi, Kayodeba. It is non-ideal have a question. Yareko. So today we are going to study and discuss about azeotropes as well as their colligative properties. Azeotropes amasung colligative property have a sige matangda punna khaminase. So let's go through the slides. So akoina azeotropes haigadi karama potsapu khangnagadagi have a sige hojik hapitang yeminase ko. So first of all, here azeotrope have a karam boigani. It is a binary mixture. Whenever we discussed about a solution amastari tabo matamda kai ha, it is a homogeneous mixture haiba. Whether it may be primary, binary or VI, ko natragana ahum component ahum thokna su yaw VI yai ko. Adu taragadi se the azeotropes hana labu sindadi kai ha. It is a binary mixture. Habadi it will consist of two components. Component ani yawgadi ba. So here the binary components which boils at the same temperature. Karamba na akoina mamangi classes singda taw matanda Raoult's law follow tawgadaba sinsi kanane hai. The component ani yawgadaba pose it will be volatile in nature habado. Aduga chamanana in azeotropes both the component or both the solute and the solvent ani maksikai ugadaba they should boil in the same temperature. Same temperature boil the haiba. That means they will have the same boiling point. And then without undergoing any change in composition, my composition no change the without haba. For example, when one component mix with another component having same boiling point, they have not to mix with each other haba. Yaiko. Habidi anido mixing the togani adubo mabani component or composition do change to we are they have. Yaraniko. Then it will be known as what? Constant boiling mixture, natragana azeotropic mixture, or simply azeotropes hanakanganiba. That means azeotropes or azeotropic mixture is a type of mixture in which the component of the mixture have the same boiling point. Same boiling point laiba component anisina binary solution or binary mixture form toragadi. It will be termed as what? Azeotropes hana khangnagani. Then after this, azeotropes have a period binary mixture ni having same composition in in liquid and vapor phase. Boiling the we already know that when we boil water, vapor comes out from that water. Hot water do steam by throtra. Ado tadi kahaba karigumba liquid amma lai taragadi magi vapor state so legani. Chumiko aduna azeotropes hai tadi kaini hai deba mase binary mixture ni which have the same boiling point. Yareko azeotropic mixture or azeotropes or the constant boiling mixture hai report say mixture amakhakni karamba solute amasung solvent. That is binary mixture amakhakni kay oigadaba constant boiling point oigadaba. Yareko that means boiling point or boiling temperature se chak managani ba component animak tugi aduna mabani gi leriba boiling point se kaidogadaba composition as well as the boiling point will be just the same and constant oini kadaida liquid ta amusung vapor state level matamda it will be as it is magi hanagi leijabado adumai dum legani ba ahong ba leiroi haini ko then azeotrope ki type makhal khara legani kana minimum boiling azeotropes maximum boiling azeotropes azeotrope to makhal se ani leireba ko adoidi ahanbagi minimum boiling azeotropes hadi kai minimum means khwaidagi sidagi hen hanaba yadre haba pot ni yai ko doidi mana kai show tawni positive deviation kanadagi Raoult's law dagi positive deviation show tawgani that means positive deviation from the Raoult's law haishi yai ko sida muna yengsi minimum boiling azeotropes oiramagadi it will show positive deviation in the previous slide mamangi slide sida happening yengsi ko positive deviation show tawriba kangu se kamai lai magi piramiba Raoult's law gi equation or masagi vapor pressure gi equation dudagi mathak lom da ka khalaka chatleba yai ko si mathak lom da ka khalaka chatliba mayam se this is the situation or the condition for minimum boiling azeotropes mixture dugi yare ko and what about this maximum boiling azeotropes hadi kai hadiba the maximum boiling azeotropes singsina negative deviation from Raoult's law so dogani hai negative deviation show taragadi kai ni hai mathak ta ka ba singdo makhada ka gani ba yare ko sida lei sumaina sigi negative deviation show tawriba sumaina mathak ta ka dabida makhada kumdhare ise ko ma je sumaina lakani haba so let's see here minimum boiling azeotropes amasung maximum boiling azeotropes ani sigi example khare yengsi ko first one this is the minimum boiling azeotropes minimum boiling azeotropes ki example sida piri se kana no yengsi diagram for mixture of ethanol and water ethanol and water ani sigi mixture se it will show positive deviation yare ko ethanol ga water ga ani sigi mixture se boiling point khara nakna lay similar and they will have what kai ogani ba minimum boiling azeotropes that means when show tawdoi se positive deviation from Raoult's law yare ko now what about this maximum boiling azeotrope show tawdoi ni kanano example di it is HCl and water acid amasung water gi mixture ko acid ka ising ka yansanare hydrochloric acid and water gi mixture sin show tawdoi se kai ne ba it will show maximum boiling azeotrope nature show tawni ba that means it will show the negative deviation yare ko so it will show what negative deviation so from this plotting we came to know that maximum boiling azeotropes as well as minimum boiling azeotropes will show deviations from Raoult's law adu edi kai orani this azeotropic mixture hana khoina hai se or the azeotropes hariba potsing se kai odeba they are non ideal solutions yare ko azeotrope khuding mak se kai oini ba azeotropes are non ideal solutions azeotropes are non-ideal solutions or mixture yarani ko kaigino because they show the deviation from the Raoult's law original Raoult's law gi masagi leijaga da masak mong dagi deviate tawraga khara nathai raga chatleba yai ko nathai ba se kalom nai thai positive as well as negative positive horiba kangu sina kai ni haba mukoi sina nasai gi minimum boiling azeotropes maximum horiba kangu sina negative deviation show tawgani haba so from this point we came to know that azeotropes are kaini haba binary mixture ore adu kai show tawni ba positive deviation as well as negative deviation show tawgani ba positive deviation show tawgada basina minimum boiling azeotropes type to ko duga maximum boiling azeotropes sina negative deviation show tawgani haba okay now let's go to the next slide Hoji akoina haudoisi colligative properties ni ko so colligative property hai taragadi akoina physical property chemical property haina nainadra physical property hai taragadi magi masak mawong da hai nacha dependent to this magi masak mawong da or color da sumai depend to ni hai greba. And when we consider about the chemical property hai tare kai da hai nasagi magi temperature do increase to ra ma tam da mawona kai change lai reaction tho o kan na kari change lai magi masak mawong sida pull up change la kare composition na change lai adu idi chemical change hai ko sumai to dana they are termed as physical properties, chemical properties in alakreba. Now, what do we mean by colligative property? Colligative property have a kaino se hapitang amu yingsiko. Yingsi magi definition ni makukto piri se ying minarasiko. Colligative properties se kaini haba are the properties. Property ama khagne karamba physical or chemical dugmaina. Property ama khagne which depends on the number of solute particles. From the very beginning, akoina yengbu matamda kai hai whenever there is a mixture or whenever there is a solution, one will be the solute and another one will be the solvent. Solute habama, solvent habama, laini habase kangreba. Adu waregadi, hoji colligative property hari karamba property. Solution amagi ko. Solution amada kana yawngi haba solute and solvent. Adu waregadi solute haba potsak to the number of the solutes have tungani yawani number of the solvent particle and tungani yawani chumiko adu already colligative property hairagadi adugumba property amani kanada depend tawba number of solute particle depend tawba that is right. So let's see again here. Colligative properties are the properties which depend on the number of solute particles. Solute particles irrespective of their nature. Whether it may be liquid or gas or solid or adubu magi nature depend taude just the colligative properties depends on what the number of solute particles that has been dissolved or that has been mixed with the solvent. Solvent ka mixed riba number of solute particle du the depend tauragadi that is known as colligative property. So here irrespective of the nature hai greko nature hai ta de kai kai ne lakto sha magi solid oibra ka gas oibra natragana liquid oibra haibasida sida depend taude haba yareko whether maybe it may be in the form of any type of this state of nature the term solid pu hek odigai di mangonda depend loi tawrani haba yarba then relative to the total number of the particles present in the solution. Nasai total number of the particles it can depend it will be depending on both the solute and the solvent. Nasai solution madam component and total number of solution today it will be the whole solution pull up to but here the colligative property is the property which depends on the number of the solute particles present in the solution irrespective of the nature. Nature really depend on the number of the particles have the solute particle depend and now let's come to the types or the magi colligative properties no have see here Roman number 1 the relative lowering of vapor pressure of the solvent to give vapor pressure. For example solute sum henjen hapchale henjen hapchan bidai marin on bagi chance handara toini chumiko so mina handara the relative lowering of vapor pressure relative lowering of vapor pressure handagiba vapor pressure thorak tu chikana no solvent tagi solute tagi thola kada tholo solvent tagi thola kani so solvent ki magi vapor pressure ki chance handagadi kai kaudiba relative lowering of vapor pressure. And what about elevation of freezing point of the solvent? Kai high elevation. Akoina elevator or lift ki thabak se kai tawe. Awang mo mafam sida kakhatna ko chingkhatna ba najra kumdarak na ba thabak toy ko. Mainly akoina lift use tore se mathata ka ba makada ko chumi ko. So elevator hana high targadi hek khanba matamda lift. Ukhala chakhinabagi ne nakhale ba ko. Aduna elevation of freezing point have matamda freezing point se hengat kidoine ba sigi case da de. Yani ko so solvent amagi freezing point se increase to halise kanana increase to haleba it is by the number of the particles of the solute present in the solution. solution duna yauriba solute particle duna maram oraga mase hengathandoineba freezing point je yare ko. And then what about depression of freezing point? Elevation of boiling point haigadabase. Elevation of boiling point. Yare ko. So elevation of boiling point hadi kaineba boiling point se increase tawdineba. Yare ko. For example, let's say an example of masagi ising asaba se da ko ising asaba se sauba se khara kabak kabak saw lerame a chini sat am thakchale na chini je thakchen ba dai ga rong 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 sorok ne yai ko adai tar ga di solute particle to hek hapchen ba ga do ya magi solution duna boil to gi chance handle tra adugi pot to ni elevation of boiling point hana lakbasi yare ko elevation of boiling point ha ga da of the solution. And depression of freezing point hai ko freezing point se depressed to giba depressed to body hantaraga leba yare ko. So depression of freezing point of the solvent kanagi no freezing point ha dan se solvent to gi yare ko. So depression of the freezing point of the solvent. Then what about this osmotic pressure or osmosis? Osmosis habitum say we have already learned it from the previous classes. That means from the lower classes like class 6, 7 lagi hauna osmosis, osmotic pressure have say kanang gitare lai chumi ko. So in this case osmotic pressure or osmosis have say si se kanya ba akoina phawdo phawjin yaba layer ama that means SPM kai hai semi permeable membrane ko sigi semi permeable membrane sidagi phawdo phawjin ya halaga just stop to wa ko phawdo pa yadre hana stop to ba solution amma se adu tare adu pressure ko kauni ba osmotic pressure kauni ba. So let's go through in details about these four colligative properties kana relative lowering of vapor pressure, elevation in boiling point ko aduga depression in freezing point as well as the osmotic pressure. Hojik makha chatharak po ina relative lowering of vapor pressure de laksiko. So let's see here. Relative lowering of vapor pressure have matam se da kai hen la e. First we take the case for the Raoult's law. Raoult's law lagi loina malatune ko. We don't take the Henry's law because Henry's law is based on the gaseous solution the base of banina mass law se laga lakte. And we take about the Raoult's law. Raoult's law sila wise kaya ba? Raoult's law is for the liquid solutions. Liquid solutions. Alright. So we take for the liquid solutions. Now let's see here. According to the Raoult's law, we have kaya gamane ba? PA equal to PA naught and XA. Kaya hai? This one is the vapor pressure of A and pure vapor pressure happening vapor pressure of A in the pure state haba. Yare ko vapor pressure of A in the pure state PA naught hai se. And then XA di kana or ni it is the mole fraction of the component A. Component A dugi mole fraction. Yaradra. Now here akoina khangba matamda the reduction in vapor pressure. Reduction hai tari kaino we will be getting the differentiation. Difference to puthorkane ba subtraction puthorko mane ko. Aduna sida koina delta PA hai. Delta PA hai se you know because we are going to find out what the difference between these two. Ani sige marakta kena budune ba puthorkta se yai ko. Amana pure form, amana solution ki form da leramba. Ani dugi marakta kena budo. So here delta PA equal to PA naught minus PA. Ani se difference tong na matanda. Kanagi term la khak thamak na bhanai no in terms of only one term. Yai ko. Components are only one term da pure oigera impure oigera adugi term la thamak na bhanari ne yaraba. So here PA naught ki term la thamak na bhanari ne si. What do we get here? PA is equal to PA naught XA. Have a khangi ko. Sige value se sida hapchalak pane ba. Yeah ba. See value se hapchalak padai we can take this PA and PA common, right? We take it common here. So the mark common logi pagi sida 1 minus XA. Yeah ko. So we get this expression. According to the Raoult's law ki matung ina ko hojika expression phanga PA naught whole into 1 minus XA. Yeah ko. Sima phange. Adu ready sida kai hai. Sige part se this sigi part se 1 minus xa hariba part se si se ga kana ga mane haba xb ga mane ha na mare yare ko we know xb have a pot se 1 minus xa ga mane from the previous calculation of Raoult's law ki calculation to bo matam da yare ko Raoult's law ki calculation to bo matam da we have already obtained that xb have a pot se kana ga mane ba 1 minus xa ga mane han logre ba yarba adoi de kai lak pe yare differentiation se similar to that of the delta pb have do ga manana pb not xb hana lak pe ya have yare ko then the relative lowering of vapor pressure is kanano the ratio of kai hai lowering of vapor pressure and vapor pressure of the pure solvent kai hai vapor pressure of the pure solvent PA naught. PA naught is the pure vapor pressure of the solvent. And then PA naught minus PA hypopotsina lowering of vapor pressure. Lowering of vapor pressure is pure ki kana khadok to no solution gi solvent to khadok na ni. Adoi di kai tare relative lowering of vapor pressure se kai ni hai ratio ni hamado ratio se kana gi ratio na line se sida kanada yen ba relative lowering of vapor pressure to the kanada yen ba vapor pressure of the pure solvent na yen thopaga managani ha yari ko sida manarabani na sigi poje kanaga manare hare xb ga manai hai kamai manai no si sina toraga sigi pojiga siga manare si sina amuk siga manare hai Chumiko. That means xb hai se kamaina manara inu haba matamda delta pb divided by pb naught. Yareko delta pb haba siga pb naught ka manaba. Si sida mana mahut sinjali se si delta pb haba siga delta pa haba siga manare the pa naught haba siga mana haba because Raoult's law ki matung ina kai hai the expression can be expressed in terms of any one of the component have never yai ko ana mana pa oigera pb oigera ani gi du term da puthok pa hanina si se kai gumba xa gi term ko manai hanadi delta pa equal to pa naught sumaina lakani ha yare ko so the Raoult's law can be expressed in terms of any one of the two components. The proof to So here we came to know that the relative lowering of vapor pressure Masagi Lazariba vapor pressure of the pure solvent to the kanana divide to ba. Lowering of vapor pressure siga divide to nama. That means the ratio of lowering of vapor pressure to the vapor pressure of pure solvent divide to ba. Yarani ko. Daidi hoji khangma ngame khoina kanada ki la a sigi process according to the Raoult's law the ki lakani ha. All right. Now in the next slide we came to know here that see the xb high se mole fraction ni chumiko kanagi component b that is solute to gineba solvent ki te ko se this is xa high gi viduna solvent ki ko then xb hana hojik la isina solute ki so here see the xb hana la ko matam sida nb divided by Na plus Nb that means this is the part to find the mole fraction. Number of moles of B divided by number of moles of A plus number of moles of B. Si pot amamam se kaina pi haba sida Nb hadadi weight of B divided by molar mass of B. Then makada amuk ani sige tungan. Lại có tôi để đi cái ta đấy PA naught minus PA divided by PA have a cigar NB divided by NA have a manarani and then WB your kind expression is my life that means see the expression see ang matam da NB part ka na manay hai this one Chumiko. Then NA part sina kanaga mana do no? This one. WA by MA have sika mana do ni. Si ani magsilo have sila kanda amaga matak makachat lagi ba. Nare ko. That means WB by MA have a potsi makado na lakto ni mag kanagi WA by WB the makala pa do. MA the matak kagi ni ba. Nare ko. That means ay haning ise NB divided by NA have a potsi kamala kani ba. WB divided by MB divided by WA divided by MA. Suman lakani haba. Si lakpasida kaida change to gani haba. WB divided by MB into MA divided by WA hana lakani haba. Sida la iba pot sini ko sida iri se. Si posinya ba sida iri se. Yare ko. Ado idi next step. XB hai se kanana ba mole fraction of the solvent na kana A do no oigre. Yare ko. Then here NB is na number of moles of the solute, NA is na number of moles of the solvent. Then pressure to the kanana pure gina PN0 ko solvent ki pure solvent kina PN0 pure na taba pressure of the solution do gina PA. Then WA is na mass of the solvent ni ko WB is na mass of the solute. Molar mass of the solvent na MA, MB is na solute ki. Yaradra. So now from here we came to know that relative lowering of vapor pressure high taraga di karamba expression na pigani ba. Sige expression sina pigani am makhada pigis. Yai ko. That means PA0 kay haba PA0 minus PA divided by PN0 na pigani. Aduga kanaga mani hai diba mole fraction nga mani hai. Karamba mole fraction, it is also XB, kanagi component B. That means solute ki. Kanada depend already tadi vapor pressure of the solution se. Nasagi solute to the depend we have the proof to it. Next, we come to the point of elevation of boiling point. Elevation of boiling point is the change to the difference in the boiling point of the solution. Nga boiling point ki elevation haram ni na ka kaida lakani ba boiling point ki difference lakani ba nga sa ko ni vapor pressure have to the relative lowering of vapor pressure have matam ja kaida la difference in the vapor pressure ana lakcha like ko adumai na hojik elevation of boiling point have matam se dadi kai lakani ba difference in boiling point alani. So let's see here the difference in the boiling point of solution and pure solvent. Kanaga gi maragta solution ga pure solvent ka ani dugi boiling point ki difference to ko na kay kawani ba elevation of boiling point na kawani hai. Yengsi ko kamay na correct na have do yengsi let T be not be the boiling point of pure solvent. TB not na pure solvent to give boiling point or rasi TB is na boiling point for the solution do ehlasi. Yani ko solution do ehlasi. Then to increase. Nasay increase to hangge hai tadi boiling point so wangkhalan do na tra. Wangkhalan do ini. But yeng isi ko. The increase in the boiling point hai se. Nasay ki difference handa da na teba. Nasay mamang ki relative lowering of vapor pressure di kay hoya. Relative lowering having na handare ba handle ba dudagi. But in this case, elevation harabani na kay dawani magi chance increase taw do niya ba. Okay? That's why the increase in the boiling point hai se kanana pini ba delta TB na pigani. Delta TB equal to TB minus TB naught. So the TB na hali ko because the boiling point of the solution is much more than the boiling point of the pure solvent. Pure solvent kito dagi hendani na solution gito lawri niya ba. Aduna TB minus TB naught hana lakpa. Yara ni ko. Then after this, sige expression sibu akoy na kay kauni ba elevation of boiling point ki expression ni hana lawani. Yara dra. Okay, now let's see here. See, ahan bagi sina generally like rani. So generally kay hara delta TB naught equal to TB minus TB naught. Yare ko. See like that. Then dilute solution high. Whenever there is a dilute solution like tadi kedarakani, elevation of the boiling point is directly proportional to kana molar concentration. Molar concentration. Habadi molality habado. Solution amagi molality, normality hana lebdo. Aduda molality duda depend awani haba. That means directly proportional to the molar concentration of the solution. Have the solution to the yariba solute ki molar concentration to the depend awani haba. Thus, delta TB have a siga kanagano small m ga directly proportional oye. And the proportionality constant is KB. KB have a say constant ni. Magi maming na kay ko diba? Boiling elevation constant or molar elevation constant. Adun na traga na ebullioscopic constant. Ebullioscopic constant. Hana sumala. Molar elevation constant or ebullioscopic constant. She anis na khwadagi common oiba term. Aduga boiling elevation constant sili yam pang use to gande ko. So always all the time ayamba matamda mostly kay sijaneba molar elevation constant or the ebullioscopic constant have term sa sijanagani. So here elevation of boiling point have matam sili kay daure kay guma solution masemo matamda solvent sita solute particles have chalaba matungda boiling temperature se increase tor a have the adu proof to sida. So now in the next slide let's see this picture. See graph or plotting se happen yang si ko sida kai ubu phange khoina vapor pressure and temperature gi plotting ni ko ta udu sya. First ahan bisi ngo TB sida le re ko TB is here then TB naught is here. TB ga TB naught ka kanan hena yame TB is greater than TB naught. So the difference between these two C part che shida gap maraitra si gap sibune ba ko na hojik elevation of boiling point hara bu thoido yare ko. So elevation of boiling point se kaina pigani hai targadi delta TB equal to TB minus TB not sinapigani haba. And according to the Raoult sogimatung ina panarapang matanda, the elevation of the boiling point have a pot se sige pot siga habidi delta TB have a pot siga kanaga directly proportional or abado de molar concentration ga oye ha. So m small m siga kanaga delta TB ga directly proportional oina kani ha. Yaradra. Now here, see what's the akun ubu phangi si yang si ko. Ahan bagi sida solvent hai ko. Sida solvent hydra hai ko. Then sida na solution hai ba. That means hujiki part sida like do vapor pressure se kana go do na solution gi. Yare ko. Solution gi. Then she part chile like the reposina kanakina solvent ki yare ko khetna ri sidani ko. That means nasagi sigi TB sina leri ba jaga se solution du gi part odine ba yar ba. And for this part sigi part sigi oina TB not na like the ba jaga se solvent sigi odine ba. That means pure solvent. Solution dana kana like ba both the solute plus solvent. Ani magyaw jaga du ba. That means hana TB not hana lerbo matam du da magi boiling point se ni maga lerbe ba yamam de ba. Adubu sida yung what about this vapor pressure? Vapor pressure ki jaga sidi ki daw ya. Ling na like that means kay haba ngasay hagi bido constant oini habdo kay buno constant oido siya vapor pressure my vapor pressure ling to bido like karino change to siya it is only the temperature kay the change to we hengalei. Yariko, pure solvent leramba temperature do kaida change tauba TB da change tawe. That means increasing taweba. Yariko, adu ide kaino sta hiding is elevation increase tawi have the proof tawi bis. Yaradra. So from this graph we came to know that when there is a pure solvent and the pure solvent is mixed with some other solute the boiling point of the solvent increases when it forms the solution form to the boiling point to increase the way aduna maram oiraga elevation of boiling point have a colligative property se puraga la e have a solution number yaraba then derivation hapitang yengisi ko derivation sida kay yawi nasagi boiling point se delta TB se ko equal to kanaga kbm ga manai habasi nasagi kbm se kaino it is known as ebullioscopic constant haboto ko ebullioscopic constant So here the temperature rise. The rise in a boiling point temperature, that is delta TB, is directly proportional to decrease in the vapor pressure. Vapor pressure directly proportional. Then according to Raoult's law, decrease in vapor pressure have a set. Delta P is equal to mole fraction of the solute. Solute depend by the holinico. Solute depend right. That means decrease in the vapor pressure will give what? Mole fraction. Mole fraction directly proportional in any high. Mole fraction is increased already. Masu decrease hand already. Man increased already. Man increased. Mass decreased already. Like amada kadaweba. For example, decrease. Sina decreased already. Mole fraction to decrease. Yariko. Seen increased already, mole fraction to increase to gani haba. Kantaraba. Ado iri according to Raoult's law, decrease in the vapor pressure decrease in the vapor pressure of the solution or the solvent kanagam concentration se manani ba. Directly proportional to the mole fraction duga manani. Kanagi mole fraction of the XP, that is solute particle. Yariko. Then delta TB have a potsiga, XB have a siga so proportional then do a KXB that means K I see kaino sige putsin proportionality sign of talking about constant proportionality constant case. Now here XA ga XB ga se kaya mane hai magi mole fraction duga that means number of the moles of the B divided by number of the moles of the A plus B hai se siga manare. Then, sige matung ina ko na sige XB value se sida hapchal ka sida XB value se sida hapchal ni hapchal matung kai pange we get equation number 2, that is delta TB equal to K and B divided by NA plus NB si pange. Then since the ideal solution is so dilute dilute oi akoy na lagu matanda dilute solution gi lawi ko hoji mamangi relative lowering gi so logi. And then see elevation of the boiling point is the dilute of a solution. So very much dilute or the amount of the solute as compared to the mole of the mole fraction of the area. We can neglect the value of NB values and neglect of Fokraniva. Then NB values and neglect of Fokramatunda, we get these. Delta TB equal to K NB divided by NA have a term say KX MA NB divided by WA. Have the A value then if NB is moles of solute oil are dissolved in 100 gram, that means 1 kg 100 gram 1 kg of solvent to sige pots. Represent the molality concentration it will be termed as this thing. kg de la molality liter de lagana molarity hydra the kg de la abanina molality term de la kb and kb se kanano k into ma ni have k into ma. So this is the derivation for delta TB equal to KB and M. Then molar elevation constant ka molar elevation constant or ebullioscopic constant have a potse karino have linga sagi kb and hari do koina kb sige kb se kaino have to ne happy si ko the elevation or the rise in the boiling point of temperature boiling point temperature is related to the molality of the solution simma kanan ha elevation of boiling point and have never so elevation of the boiling point in a delta tb equal to kbm have a potse like that then the molar elevation constant may be defined as kai hana defined the way elevation in boiling point temperature for 1 molar solution molar elevation constant high taragadi elevation in boiling point temperature for 1 molar solution molar amakhaki solution 1 molar solution that is the solution in which 1 mole of the solid is dissolved in 1 kg of the solvent 1 kg of solvent 1 mole of solid dissolved the matam da legadaba elevation in boiling point to bu koina molar elevation constant or molar elevation constant or this ebullioscopic constant ko we have that means boiling elevation constant higher su yabani chamane ko boiling elevation constant ko boiling elevation constant or molar elevation constant or kana haba ebullioscopic constant ahuma ke chap mana po ani kb have bots ni ko ete kb have a post calculate gi hai tarde kai season ani ba kb equal to mr delta t p naught square divided by 1000 into delta enthalpy of vaporization yare ko enthalpy of vaporization se use torakani seda m have sina molar mass ni ko adegi ngasagi r high sina real gas constant delta t high propose delta tb high sina molar elevation constant to gi masagi freezing boiling point ne karamba boiling point temperature at which pure solvent orikan gi matam ki ko then sida kb high propose magi unit se kaino degree per molality degree per molality harne namani kai de pirane degree celsius m degree celsius per molar or kelvin per molar or kelvin kg per mole so for today let's stop here and in the next class we will be discussing about the depression of the freezing point amasung osmosis and reverse osmosis siguma mayam sing si tawminasi. So for today, let's wind up at this elevation of boiling point. In the next class, we will recap the previous classes tawgiba sing du supuna recap tawminasi amasung makhataba chapter sigi makhataba topic sing chathaminasi ko till then be happy, be safe, study well, bye bye.